Welcome. This is Chapter 6, Bonds and Bonds Valuation. And this is the first part of Chapter 6, following other learning outcomes from this presentation. Students, after going through this presentation, should be able to understand the basic bond terminology, apply the time value of money equation in pricing of bonds, and later on, students should be able to analyze the difference between annual and semi-annual bonds, and analyze the pricing of zero-coupon bonds. But with respect to annual and semi-annual bonds, students should also be able to analyze how the fluctuation of bonds prices occur because of changes in interest rates, and how long-term bonds are more sensitive to interest rates than the short-term bonds. So the students would also be able to deduce the effect of bond ratings on bond prices, bond issues, etc. And students should be able to price the government bonds and notes based on looking at their time to maturity and yield to maturity. We have not defined these terms yet, but we're going to define them very shortly. So let's apply the time value of money equation first in the bond pricing equation. So a bond is a long-term debt instrument if issued by the government or corporations, and the borrower in this case, so remember, the issuer is a borrower, and the borrower or the issuer promises to pay some funds at regular intervals of time, which act as a proxy for interest payments and the lump sum at the end of the bond's maturity date. And this lump sum usually is called the face value or the par value, and these specific payments are always a contractual obligation which is written on the bond. So the bond will always say that this is the payment schedule of cash flows for this particular instrument. So the key components of a bond, as you might have noticed already, are face value and par value. They're interchangeable. Face value is the same as par value. So par value or face value is the principal amount. It's a notional amount. It may or may not be received by the borrower or the issuer at the beginning of the bond's life. They could have received an altogether different sum at the beginning, and we'll see why. So this is the principal amount. The only thing that is important to note about face value is it's a fixed amount, and it's a contractual obligation of the borrower or the issuer to pay this value to the lender, whoever is holding the bond, at maturity. Maturity is the last day of payment. We'll talk about it in a minute. Let's move to the next concept, the coupon rate. The coupon rate is a percent of the face value. Notice the face value is fixed. So the coupon rate or the percentage of the face value will always be fixed as well. So that tells us that, so let's assume the bond's face value is $100 and the coupon rate is 12%. That means that the bond issuer or the borrower will always pay out 12% of $100 or $12 at fixed intervals of time. So that is coupon in dollars. And since the coupon rate and the face value are both fixed, the coupon dollars are also promised dollars payments. Next is the maturity date or the expiration date. Maturity date is the date at which the final payment of the bond is made. So there is typically one last coupon payment, and the par value is paid out at maturity, the last date of the payment. So this is the final payment of coupon and the par value. Finally, the yield to maturity. So one might be wondering, what happens if interest rates change as the bond has traveled along its life? So the yield to maturity is, which is also the discount rate as we've seen in the time value of money equation, or the rate function, that rate is yield to maturity. Coupon rate is just a notional rate which actually gives us the intermediate payments that the bond is making to the lender at any given point of time. So the bond's discount rate or the return to the bondholder is that rate at which we will discount these coupon payments and the face value to achieve a certain present value of these cash flows of the bond. One more term that one must understand is a time to maturity. So it's the difference of the maturity date and today's date in number of days that remains for the life of the bond. So for example, if we say a 10-year bond then the time to maturity of the bond is 10 years. If we say a 312-day treasury bill, then we know that the time to maturity of the bond is 312 days. This is also called the duration of the bond. The duration of the bond is the time left from today until the maturity date. So now let's price a bond. How do we price a bond? Well, as we saw, a bond is kind of a hybrid of an annuity and a final cash flow. So we will see that in a picture coming up just in a minute. So as we have seen kind of notionally so far that there are coupon payments, which is kind of a fixed value that keeps repeating itself over regular intervals of time. But the problem is the last coupon that is returned to the lender comes with the par value as well. So it's not really an annuity because annuity payments are fixed throughout. In a bond, the coupon payments are fixed, but the final payment that is made is coupon and a par value. So a bond is kind of a hybrid annuity in which it has a mixed cash flow structure. So what we need to do is, just like any other variable cash flow stream, lay out the timings and the amount of future cash flows. Then find out what's the going rate of interest or the discount rate. Once we do that, we can discount the cash flows to find the present value of each cash flow. Then we find out the present value of the final cash flow and add all of these present values to get the price of the bond. So let's price a 10-year bond as an example. So let's assume that the bond is maturing on November 5, 2035. It was issued on November 5, 2015. So this is a 20-year bond from its issuance. But as of today, let's assume today is November 6, 2025. So it just paid out its coupon payment yesterday. And today we are at November 6, 2025. So there is another 10 years left for the bond. So that's why it's a 10-year bond. It's no longer a 20-year bond. The face value of this bond is $1,000 and the coupon rate is 3%. And the bond, for simplicity, we will break this assumption, is paid out annually. So the coupon is 3% of 1,000. We'll calculate that in Excel. Is $30. And suppose the yield to maturity or the discount rate is 2%. So let's lay out the cash flows into Excel. Going to Excel now. So since it's a 10-year bond, 1 equals this plus 1 to 10 cash flows, 2 to 11. These are our 10 cash flows, equals 3% of 1,000, $30. And then black cross and double click. Wait, the last cash flow is not $30. It should be this plus the face value. That's 1030. So that's the first step. Lay out the cash flows. One must see how the cash flows of a bond look like. So these are all coupon payments. Let's just write them down. Coupon payments, Alt NU, and then use the left arrow, insert, close. Oh, we should have said coupon afterwards, not before. Coupon. That looks kind of funny. Not funny at all. Shift Control comma. Nope. Make it smaller. All right, and then Control D, 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 but this is not really coupon, this is coupon plus face value. Or par value. Okay, that's how the bond payments or cash flows look like. Now these are all positive for a lender. For the borrower, it's going to be exactly the negative of this. So these are the coupons and the final payment. For the borrower, these are all negative because they go out from the lender's side. Okay, so in the pictorial form, it looks like this. At t equals 0, the borrower receives some money. In return, the borrower pays $30 at t equals 1, $30 at t equals 2, and so on till t equals 9, $30, and then t equals 10, the $30 as well as the $1,000 of par value or the face value. So we can, in other words, write down the present value equation as C1 divided by 1 plus R, C2 divided by 1 plus R squared, Cn divided by 1 plus R to the power n. Now notice C1, C2 through C9 are the same. So it can be represented as a constant cash flow C. But the 10th cash flow is not really the same as the 9th or the first cash flow. That's why we just said, why don't we just represent them as different cash flows? Now, here we go. So now remember, the rate of discount was 2%, or the YTM, yield to maturity, is 2%. So we put that in denominator and add 1 to it. So 1.02, 1.02 squared, 1.02 to the power 10. And then, so the $30 here comes from here. And this $30 was, remember, the 3% of the par value. And so 30, 30, 30, 10, 30. And in our example now, 30 is a coupon, 1,000 is a face value, and 3% of the face value or the coupon rate is $30. 30 divided by 1,000 is 3%, called coupon rate. Notice how the coupon rate is not the same as the yield to maturity. Coupon rate is fixed. Yield to maturity changes with the market in the denominator. That's one important thing one must know. The time to maturity or the duration of the bond is 10 years. And so let's go back to Excel to find out the present value. Now, this is where the loan concept comes in powerfully. So there are two ways to do this. We're going to do this by using the standard method, in which we just do equals this divided by, wait, we have to first put 2%, right? So equals this divided by 1 plus $D $1 to the power of $A1, and then black cross, double click. So these are all the present values of each cash flow. And notice how as the same cash flow goes further and further out, its present value decreases. And then we add these two, all of these together, we get, now this is somewhat strange, hold on, divided by A2, I apologize, good catch. And then add these together to get the price of the bond. So the price of the bond is 1089.83. That's exactly what we got. Now we can get this as a in a different way, just using a simple PV function. So the number of periods is 10. The number of periods is 10. Wait, the rate is D1 in the cell D1, as you can see. The number of periods is 10. And let's assume we're still the lender. So we get these positive cash flows. So the payment is 30. And on top of these payments, so annuity, on top of the annuity, we get the final cash flow of the par value. And the type is 0. So again, the rate is the YTM, number of periods is the time to maturity of the bond. The payment is the coupons. So it's the coupon rate times the par value. The future value is on top of the coupons, we get the face value back. And the type is 0 because it's end of the period payments. We will get the same answer, 1089.83. Why is it negative? Because since we are the lender, we receive the coupons and the face value at maturity. But in order to do that, we must save now. So we have to pay out this price today. So notice how, if I look at it from the issuer's perspective, the price that the issuer received or the price that the lender paid is not equal to 1,000. And that's why we said that only constant thing about a bond is the par value is received at maturity, and the coupon rate is a fixed rate of the par value. So the coupon payments are also fixed. Given all that information, this is how we find out the simple price of a bond. To conclude, a bond is a debt instrument with fixed cash flows. These cash flows are called coupons, which are a coupon rate times the par value. Both the coupon rate and the par value are fixed. Therefore, the coupon value in dollars is also fixed. So the face value of the par value is the value paid out at maturity to the lender. Usually coupons are not paid annually, but they're paid semi-annually. So what do? Well, we just have to change our cash flows accordingly. So our example was annual coupon payments. And the price, importantly, is a present value calculated from TVM equation. We also saw how the price could be calculated using two different ways. One was finding out the present value of each cash flow, and second, just use the PV function. But in the PV function, use it as annuity and a single different cash flow. That's chapter 6, part 1. Thank you for listening.